This is Twitter Think. Please take some few seconds to subscribe to this channel and support this work. My name is Daniel and I have for you here methods of Laplace transform. And this is example 2, part 1. This question is a little bit complex, so I'll split this video into two and I'll treat the first one as part 1 and then treat the second part of the calculation as the part 2 so that I can reduce the length of the video. So previously I discussed a first example under this same topic and I taught you how to change a differential equation into Laplace transform using partial fraction to solve and using inverse of Laplace transform to deduce the final answer or result. So in this one, this is very similar. It says we should solve the pair of differential equations 2y dot minus 6y plus 3x equal to 0 and then 3x dot minus 3x minus 2y equal to 0. And we have been given the initial condition at t equal to 0, x equal to 1 and y equal to 3. So anytime you have a differential equation in this form, you need to know what you are working with. So the first step is to transform x dot and y dot. X dot and y dot are first derivatives of the variable x and y. So we transform them into Laplace transforms and we continue the calculation. Okay, so now let me take you here. Now look at this. If I have f of x function giving me x, assuming f of x is equal to x, then the first derivative of the function f of x, which is f bar or f1 of x, will give me x dot, like I said. And then in the same way, if I have a function f of y, which is equal to y, assuming I have y equal to this, then the first derivative of this is the same as y bar. So we can change all this into what? Laplace transform. So in Laplace transform using notation, y dot, which is first derivative of y, is the same as s y bar minus y naught. Okay, so that is it. Then we go to what? X dot, which is this one, which is the same thing as x bar minus x naught or x subscript 0. Then we move on to the variables x and y, which is here. So in Laplace transforms, x is equal to what? X bar. Then y, the Laplace transform of y, is the same as what? Y bar. Now that we have been able to convert everything into Laplace transform using notations, we can substitute this back into the equation, okay? Now, let's substitute this result into the equations above, okay? I don't want to be shifting the paper, so I wrote the equation here. Now, wherever we see this, we put in this one. So, we have here 2 into bracket s times y bar minus y naught minus 6. Wherever you see this one, substitute what? Y bar. So, minus 6 y bar plus 3 x bar equal to 0. Then we move on to 3 into bracket. We substitute this, which is x bar minus x naught, and then minus 3 x bar minus 2 y bar equal to 0. So now we substitute the initial condition at t equal to 0. X naught will be equal to 1. And then y naught will be equal to 3. Now we already have our x naught and y naught here, so we can put in the initial conditions. So these are my conditions. So let's substitute that. So this is giving us 2 into bracket s y bar minus 3 minus 6 y bar plus 3 x bar equal to 0. Then the second one, we have 3 into s x bar minus 1 and minus 3 x bar minus 2 y bar equal to 0. Alright, so we can expand this bracket by having 2 s y bar, this time this minus 6 y bar plus 3 x bar equal to 0. Then we expand the second equation. We have 3s x bar minus 3 x bar minus 2y bar equal to 0. Now, the next thing we need to do is to rearrange the equation in terms of x bar and y bar, then the constant, okay? Then we can factorize it. So let me start with this one. So I have 3x bar, then let me move on here, plus 2s y bar, then to this side, minus 6y bar, then to the constant, negative 6 equal to 0. And let me do the same thing here. This is 3s x bar minus 3x bar minus 2y bar minus 3 equal to 0. So from here, I can factorize y bar here, and I can factorize x bar here. Okay, so this is giving us, we have 3x bar plus 2s minus 6. Okay, put this in bracket, y bar equal to, let's cross the constant to the other side, equal to 6. Then we can factorize 3s minus 3 into x bar minus 2y bar, giving us what? 3. So label this equation 1, and this is equation 2. Okay, so now at this point, looking at equation 1 and 2, we are going to solve for x bar and y bar, okay? X bar and y bar. So we will first find the solution of x bar, then in the second video, which is the part 2 of this one, we will find the solution for y bar. All right, so how do we find x bar? Now, it is very important for you to decide between x bar and y bar, which one you want to solve first. If I want to solve x bar first, which is what I want to do now, then I need to find a way to eliminate y bar out of the equation so that I can work on only x bar. Now, how do I eliminate y bar? Look at this very carefully, and I want you to listen to me. We can use elimination method to do this. Now, before I can eliminate y bar, I need to make sure that the coefficient term of y bar, whatever I have in this bracket, is the same as what I have here, because these are two simultaneous equations. If I am able to make the second equation have its coefficients, which is the value in front, to be the same as 2s minus 6, then I can either add or subtract to get rid of what? Y bar. This is when you have to look at the equation very carefully and think. Listen very carefully. Because these are two simultaneous equations, we can use elimination method to do this. Now, in elimination method, the coefficients of the variable we have to eliminate must be the same. You and I are aware of that. If they are the same, we can either add or subtract to make it 0. Now, when you look at these two equations, the coefficients of y bar here is 2s minus 6. The coefficients of y bar here is negative 2. The question is, how do I change this value to be the same as this, so that I can either add or subtract to eliminate y bar? Now, when we look at this very carefully, I can use s minus 3 to do this, so that if I multiply this by negative 2, which is here, this time this will give me what? Minus 2s. This time this will give me what? Plus 6. Okay? Then my y bar. As you can see, this and this are now the same, though the sign here is different. Now I can either add or subtract, looking at the function, to eliminate what? Y bar. So what we need to do is that we have to multiply equation 2 by s minus 3. So by multiplying by s minus 3, this is the result I got. S minus 3 times this part minus 2y bar times s minus 3 equal to 3 times s minus 3. I cannot expand this here because this space is too small. So let's do this on a fresh sheet. So now let's expand the equation. S times 3s, we have 3s squared. S times this is giving us minus 3s negative 3 times this, we are having minus 9s, and then this times this, we are having plus 9, multiplying x bar. S times this, we have minus 2sy bar. Then 3 times this is giving us plus 6y bar, giving us 3 times this, we have 3s minus 9. Okay, now let's factorize y bar out here. So we rewrite this equation by having 3s squared minus 3s minus 9s plus 9 times x bar. So we can now factorize this negative out, minus into bracket 2s minus 6 bracket close y bar. So that this time this minus sy bar, this time this plus 6y bar, giving us 3s minus 9. We can label this side equation 3. Now when you look at equation 1, you see that we are having a similar thing in equation 3. Okay, so let's recall equation 1 and see what will happen. Now when you look at equation 1, we have 3x bar plus 2s minus 6y bar equal to 6. You see this and this are now the same. The sign here is negative, the sign here is plus. So once we add these two parts of the equation, this side will be resolved to 0. Now do we get it? Then we can add this and this, and we add 3x bar to this result. Remember that the coefficient we have here is 3. It is a constant one. Okay, so I can add this 3 to 9. I don't want to expand this side before I add and then group like terms. It's a waste of time. Okay, then this 6 can add to this one. This and this will now cancel. So we add equation 1 and equation 3. So because I want to avoid expanding this side before I add this part of the equation, I will add it this way, like using elimination method. So let's start with equation 1. So we have 3x bar plus 2s minus 6 y bar equal to 6. We have 3s squared minus 3s minus 9s plus 9, or x bar, then minus into, we have 2s minus 6 y bar equal to 3s minus 9. We can underline this. Oh, my line is not straight. Anyway, so we add the result. So now we are adding equation 1 and equation 3. So this is how we add. We don't have an s squared term here in equation 1, so we repeat it, 3s squared. We don't have an s term here in equation 1, so minus 3s minus 9s. In fact, I was supposed to add this to give us 12, but I'll do it in the next step. Okay, so now we have a constant term here. This and this we can compare, they are the same, so we add the value. 9 plus 3 is giving us what? 12. So 12 x bar. And when you look at this, this and this are the same, so this and this will cancel. Okay, so they are out of the calculation. It giving us, we have 6 and these are common, so we can add it, giving us negative 3. So we have 3s minus what? 3. And we can label this as equation 4. When we rearrange equation 4, we have 3s squared minus 12s plus 12 times x bar, giving us 3s minus 3 as our equation 4. Now from here, we have been able to eliminate y bar, so we can work on what? X bar. So we can make x bar the subject of the equation. But before we do that, we can see that there is a common factor here. We have 3 here, we have 12 here, we have 12 here, and we have 3. So we can divide the equation through by what? 3 to break it down. Okay, so when we divide this by 3, what are we having? We have s squared minus 4s plus 4, all multiplying x bar, giving us s minus 1. this is equation 4. Okay, so I've broken it down to the simplest form. All right, so now we can make x bar the subject by dividing through by what? S squared minus 4s plus 4. When we do that, this will cancel, giving us what? X bar equals s minus 1 all divided by s squared minus 4s plus 4. So you see, this is x bar. We are not done with this calculation yet. Okay, now we have a quadratic equation at the denominator. I don't need to factorize this. Use your calculator to find. I don't have a calculator with me here. When we factorize this, this will give us a repeated factor. Okay, when you punch this on your calculator or you factorize this, the result will give you s equal to 2 and then another s equal to 2. So we cross this, giving us s minus 2, then another s minus 2 equal to 0. Okay, so we can take the product of this, giving us s minus 2 all squared because they are the same. So this is a repeated factor. All right, so if this is a repeated factor, then we can resolve this into partial fraction. So x bar is giving us s minus 1 out of s minus 2 all squared. Do we get it now? Now resolve this part of the equation into partial fraction to find the constant a and b. So let's do this calculation on a fresh page. Now partial fraction says that if you are resolving something like this and you have a repeated factor, then into partial fraction, it is going to give you a over the first one, s minus 2, plus b over s minus 2 all squared. Okay, so this is how you resolve a repeated factor into partial fraction. So resolving this into partial fraction, we have a over the first s minus 2, do not square that one, plus b over s minus 2, then you can square it for b. Okay, now we take LCM on the left hand side. I don't need to be doing this, but for the sake of explanation, okay, so the denominator will give us s minus 2 all square. Now this s minus 2 can cancel one of this because we have twice of this one here. We are left with only s minus 2, which will multiply a. So we have a into bracket s minus 2 plus this and this are the same. They will cancel. We are left with b. So 1 times b will give us what? B. Now, because the denominators are the same, partial fraction says that equate the numerators. So equating the numerators, we have s minus 1 giving us a into s minus 2 plus b. Now we need to find the value of a and b. We can apply cover up method here. So to apply cover up method, we can cover a and then find for b. So how do you cover? Pick the bracket, equate it to 0. So this bracket, I don't have a square term here, so it's very easy for me. So when s minus 2 equal to 0, s is equal to 2. Cross it, okay? Wherever you see s, substitute what? 2. So this is giving us 2 minus 1, giving us a into bracket 2 minus 2 plus b. So this and this will give us 0. A is out. So 2 minus 1 is giving us 1 equal to what? B. So therefore, b equal to 1. Now, we need to find for a. Because I don't have any bracket here to equate to, I can pick any random value of my choice, okay? Let's pick the easiest value that we can use, apart from 2. So let's use 0. So when I substitute 0 here, okay, I can work for b. So when s is equal to 0, wherever you see s, substitute what? 0. So we have 0 minus 1, which is coming from here, the left-hand side of the equation, will give us a into 0 minus 2 plus b. You know the value of what? B, which is 1. So this is negative 1, giving us a times this is minus 2a plus 1. I need to avoid this negative. So I'll carry this one here and take the negative one to the right side of the equation, giving me 2a is equal to 1 plus 1. So a giving me 2 out of 2, which is 1. Okay, so now we have been able to find the value of a and b. So substitute the result here into this part of the equation. Okay, so this becomes x bar, giving us a is 1 over s minus 2 plus 1 over s minus 2 all squared. Now, what are we looking for? Okay, so now that we have gotten here, we have been able to find x bar, but that is not the solution. We need the result for what? X. The result for x. To do that, you need to find the Laplace inverse of this result. So the Laplace inverse of x bar will give us x. What will be the Laplace inverse of this one? Let's find out. So we take Laplace inverse of x bar, giving us the Laplace inverse of 1 over s minus 2 plus 1 over s minus 2 all squared. Okay, so previously I taught you how to find the Laplace inverse of an exponential function. Okay, and we learned that the Laplace transform of the function EAT will give us the result 1 over s minus a, where a is where a here is a scalar. Okay, so it can be any positive or negative number. Now, that is the same thing that we are seeing here. So if I have this, the Laplace inverse of 1 over s minus a will give me this result, e to the power at. If this side is negative, this side will be positive. Are you getting it? Assuming I substitute a value here, giving me 1 over s minus 3. Okay, then the Laplace inverse of this is going to give me e to the power 3t, where this 3 is a scalar from this side. If this side is positive, this will change to negative. Okay, so it will give you e to the power negative 3t. So I've done all these things in the same playlist. You can locate this video, Laplace transform of e to the power at. There is an example there that will help you to understand this concept. So the Laplace inverse of x bar here is giving us what? X being equal to the Laplace inverse of this. We have e to the power 2t, then plus Laplace inverse of this is giving us what? E to the power 2t. Now watch very carefully. There is a square here. Because of this square, you put t here. So this square will make you write a t here. This rule, I'm not sure I discussed this on the channel. I think this rule is coming from multiplying by t. Okay, Laplace transform of t times a function f of t. Okay, where f of t here is standing for e to the power at. Okay, now you can locate this. I'll try my best to see if I can put this on the channel. So multiplication of t, anytime you find something like this, you multiply by t. If this side is cube, I've not really read about that. Usually I come across 2. So if it is squared, you use the multiplication of t method. All right, so you leave your answer here. So this is the result for what? X bar, giving us x equals e to 2t plus t e to 2t. And this is our final result. We are not done yet. We are still yet to work for y bar. So meet me in the part 2 of this same video. Method of Laplace transform and partial fraction, example 2, part 2. And I'll take you through the solution for y bar. Thank you for joining me here. My name is Dan. I'll see you in the next one.